We'll now look at Hamming code, error checking with Hamming codes. And once again, I'd like to reference the Wikibooks wiki site, A-Level Computing, where I've borrowed most of this material. So we looked at parity bits used for error checking when sending data. We looked at odd and even parity. If this is our data and we're using odd parity, then we need to have an odd number of ones. So we set the parity bit to a 1. So we'll have 1, 2, 3, 4, 5 ones in this case, which is an odd number. If we're using even parity, and this is our data, we set the parity bit to 0 to keep the number of ones even, 1, 2, 3, 4. Hamming code is similar, but it checks data when it's being transmitted, and it can also correct it. So it corrects errors in transmission. And what you do is you number the column headings, highlight the column headings that are powers of 2, 1, 2, 4, and 8, and these will be the parity bits. Then insert your data and highlight the parity bits. Then work your way through the data. We're doing something called check, skip, check, skip, check 2, skip 2, check 4, skip 4. So look at this example. So we insert our data, and we have the number of headings, 1, 2, 3, 4, 5, all the way up to 11 here. We insert the data, and we highlight the check bits. So that's 1, 2, 4, and 8. So we've underlined them here, they're highlighted. Now we work our way down the data. We check and skip, so that means we pull these numbers down, so we blank out every other one in the first instance, starting from the first power. And in this case we're using odd parity, so we check it 1, 2, 3, odd parity. Now we start at 2 and we check 2, skip 2, check 2, skip 2. So we just, starting at 2, we borrow this 2, we skip 2, then we borrow this 2, we skip 2, and then we pull down this 2. And 1, 2, 3, we've got odd parity again. Now in the third power, we start at 4, and we check 4 and skip 4. So these are the 4 that we pull down. 1, 2, 3, 4. And it's, once again, we count the number of ones, and it's odd. So that's odd parity, so it's fine. And finally we start the 8 column, and we check 8, skip 8, but we've only got 4 here, so we just do the 4. And once again we count the number of ones, and we've got odd parity, so this is worked, this is fine. This has been transmitted correctly. Let's look at one that's been transmitted incorrectly, and we'll see that we have our data, and we check 1, skip 1, check 1, skip 1, and we have 1, 2, 3, 4 numbers of 1, even parity. We check the next column where we start at 2, check 2, skip 2, check 2, skip 2, and we have 1, 2, 3 ones, which is a problem because it's odd parity. Once again we start at 4, we check 4, skip 4, and we count the number of ones, and we have 1, which is another problem because it's odd. Then we start at 8, and we check 8, skip 8, but we've only got 4, so we just check these 4, 1, 0, 0, 1. And we've got 1, 2 ones, so this one's fine. So we need to find out where the problem is, and we can look, and we have the problem in the second power of 2 and the third power of 2, which is 2 and 4. So if we add 2 and 4, we get 6. So if we flip the bit in number 6, if we flip this bit, because adding 2 and 4 tells us which column the problem is in, if we flip this bit, then we'll find out that these are all even parity. So let's look at the same one, and we flip the bit in column 6 to a 1, and we find out in each of these, 1, 2, 3, 4, we've got even parity, and 1, 2, we've got even parity here. We have even parity in all of them, and now it's correct. And that's how we do Hamming code. So you practice a few of those with different binary numbers, and you'll begin to understand it, and you'll be able to get that correct. This is for error correction and error checking and correction in data transmission. Thank you.